Is 32 millimeters apart.
Even the top one?
So 2 millimeters?
No, those two are different because those are for the hinges.
For hinges, yeah.
So that's done on its own thing. And that's done, we do it. We used to do it off of a 32 millimeter system, but we now do it off of the end of the door.
Okay.
So coming off the end of the door makes it easier for us to set up another machine out there where we drill off of the edge of all of the doors the same distance no matter what this line is in the middle. So the cabinets can be all different sizes and this can be wherever it needs to be. When we first started out, we didn't have the capability to do that. So
What machine does that?
CNC.
What CNC that was?
The CNC does the holes?
Yeah. So we've replaced any holes in the flat surface with the CNC. We used to do it on this machine. So that's fixed head boring. So fixed head boring would only do 32 millimeter spacing. The CNC does not do fixed head boring because it's a drill bit.
Right.
I can put it wherever I want it. If I wanted these holes to be an inch apart, I could make them an inch apart. That's a whole nother level of technology, like a newer level of technology. So at some point, these machines, this 32 millimeter system, will kind of phase out because everybody will be able to do it wherever they want with that. So this was the 20th century, and that's the 21st century.
Do you put like 2 hinges or 3 hinges? Like one, 2 end and one
two on this one.
2? Or?
We have to get up over like 40 inches before we put a third hinge on.
Okay.
It depends on the weight of the door. There's parameters about the hinges, so you go in and there's a specification that says if the door is this wide or this weight,
Right.
you need 3 hinges. If it's some other weight, if it's less than that, don't worry, you can get away with it too. So that's line boring. This is called construction boring. So construction boring is what is the replacement for biscuiting. So construction boring would require the holes on the face of the board, and then I would have to have holes in the end of the board that would match those holes to go together. Okay? This machine is a construction borer. It will do holes on the face of the board, and it will do holes on the edge of a board. A line borer will only do holes on the face of a board. And it has to do with how you can adjust the machine. So, our construction borer, you can see right now the bits are horizontal, right? The bits are drilling towards us.
Yeah. You flip it up?
I can loosen this here and the big handle. Now the bits are facing up, I can drill into the face of the board. Okay? A line borer will either be fixed like that where it drills up or fixed where it drills down. It won't have any ability to do that. It's a much cheaper machine, but it's much faster at doing lines than this.
So
we used to have both machines.
Uh-huh.
But when we got the CNC, we stopped using the line borer because we replaced all of the line boring was done on the CNC. We kept that machine in here for like 3 years so we could show you guys how to use it. And then at some point, we needed to replace our bandsaw and our jointer because we had a real crappy bandsaw and a real crappy jointer, and we sold the line borer, make enough money to buy the bandsaw and jointer.
So do you still use this to make stuff?
Yes, because the CNC has no ability to drill into the side of a board. I can only drill into the face of a board.
Why is that? Why is the CNC incapable of that?
Because we're using what's called a nested-based router, 3-axis router. It only drills vertically.
If you had the 5 one, would you be able to do it?
Yes, except if you're doing nested base, which is what we do, where you take a sheet and put it on there and you cut all the parts out of the sheet. You still can't do it because you have parts on the sheet, they get cut out. I don't know if you come over and see them get cut. They get cut out and they're that far apart. There's no way to get in there and drill those edges. So we couldn't do it anyway, even if it was a 5-axis machine, if it was a flatbed router, which is what that is. There are other systems where people will have what's called a beam saw, which is like a great big machine. Think like 3 or 4 times the size of the CNC router. That is like a saw blade that goes across and cuts the boards up. So it quickly, more efficiently than the router, will cut rectangles. Those rectangles will get stacked and then we'll be putting another CNC machine that will drill into the face and drill into the edge. And it will have heads that can go, it can be vertical. There are machines that are vertical. You just run a piece in and heads come down this way and this way. There are machines that are called pod routers, big like that, but they have suction cups that will hold a single piece and it'll come down and drill and then it'll go turn and drill the sides all the way around. But it's a different setup. We, one, couldn't get into the beam saw. It's just too expensive and too big. And 2, if you're a small shop, you probably want to start out with like a nested base router. Just is more efficient for a small shop to do that because we can do more things with less money than if we try to go big.
So like.
What we could do though is we could replace this machine with a machine that just drills edges.
Okay.
And it's a single drill bit that goes one, it needs to be keyed to that machine. So both machines need to be tied together in the software in there because it needs to
Speak to it and tell it what's the pieces.
then it needs to also have, we need to have a barcode reader because it would be impossible for a human to know
Which pieces?
which piece goes in which thing. So the machine's got a barcode reader. You have to put the right barcode on the right part. It would read the part, then it would know how to drill the edge of the part. And 3, we would need to have about 60 grand to buy the machine. So we're talking about $100,000 investment at least to drill into the edge of the board.
That's a lot of money.
We don't have that.
The
We
JMP.
never demonstrated that we could make enough money for them to buy us more than the CNC router. If we could have made like $1 million in a year, which we got for like $500,000 one year, and still didn't make a whole lot of money, they probably could have swung to get this machine, but we never did. At least Scott got burned out. Chris, too much work.
What is a machine that you would love to have in the shop that's so expensive?
You gonna buy it for me?
Maybe after the lotto.
Yeah,
I have a scroll, so I don't need a scroll. I would like to have this machine that does this other, this
What
edge.
about a beam saw? Like,
It
what
won't
about
fit. It won't
a
fit.
5-axis
It won't-
suction?
They won't fit. If you want to give me a 5-axis router, I can put my garage. That's great. Brooklyn can't use a 5-axis router. We could use this. We could use this. We could use nicer, table saws and things like that. Bandsaws that work that we don't have to replace the switches on. But it would be nice to have this. It would help us out in production. Really help us out because this is like a bottleneck. Because this is an older technology and it takes somebody has to set it up. And it's always Angel that has to set it up because we've taught Angel how to do it. Prior to that, it was either Scott or myself, and it was really a bottleneck in our production. It was one of the reasons that we bought the CNC router was to get around most of setting this machine up. And also the number of generations of our cabinets. We first set it up one way, I'll talk about that in a second, and it was inefficient. And we built cabinets like that for 2 or 3 years that it was really inefficient. We made lots of mistakes. and then we set it up, we came up with a new system that's really only works for us. It wouldn't work for